The silence of the universe is not empty. The universe looks quiet. When we look up at the night sky, we see stars, distant galaxies, and endless darkness. At first glance, space appears calm, empty, and silent. But that silence is one of the greatest mysteries humanity has ever faced, because the universe should not be quiet. It should be loud. The universe is nearly 14 billion years old. It contains hundreds of billions of galaxies. Each galaxy holds hundreds of billions of stars, and many of those stars have planets. Some of those planets orbit in regions where liquid water can exist, where chemistry can evolve, where life, at least in theory, should have had more than enough time to appear. Not once, not twice, but millions of times. And yet, when we listen, we hear nothing. This contradiction has a name, the Fermi Paradox. If intelligent life is common in the universe, then where is everyone? Why don't we see massive structures built around stars? Why don't we detect artificial signals crossing the galaxy? Why hasn't anyone visited, contacted, or revealed themselves? The numbers say they should exist, but reality says otherwise. And that gap between expectation and observation is where the fear begins. For decades, humanity has been listening. We built radio telescopes. We scanned the sky. We searched for patterns in the noise. And most of the time, space answered us with silence. But sometimes, the silence breaks. Occasionally, we detect signals that do not look random. Short bursts of energy, repeating patterns, frequencies that stand out from the background. Each time it happens, excitement rises, and each time the explanation eventually returns to something natural. A pulsar, a magnetar, a strange but explainable cosmic process, except for a few cases that never fully settled. One of them lasted 17 years, a signal that appeared from deep space. It repeated at the same frequency, from the same direction, year after year. Natural processes rarely behave with such precision for so long, and then, without warning, the signal stopped. No transition, no fading, just silence again. To this day, there is no explanation that satisfies everyone. That silence forces us to ask a darker question. What if the universe is quiet? Because staying quiet is the only way to survive. Imagine a galaxy filled with civilizations. Some expand, some transmit signals, some announce their presence, and some disappear. Not destroyed by accidents, not erased by natural disasters, but removed quietly. If advanced civilizations learn one thing early, it might be this: drawing attention is dangerous. In a universe this old, predators would have had billions of years to evolve. Not biological predators, something far more efficient, something patient, something that doesn't rush. This idea is sometimes called the dark forest hypothesis. The universe is like a dark forest at night. Every civilization is a hunter, moving silently between trees. No one lights a fire, no one calls out. Because the moment you reveal your location, something else might already be listening. Humanity, however, did the opposite. We sent radio signals into space. We broadcast our location. We launched messages containing our DNA, our languages, our coordinates. We did not whisper. We shouted, and we assumed the universe was empty enough that no one would hear. But what if the universe isn't empty at all? What if most of it is simply invisible? Modern physics tells us that everything we see, stars, planets, galaxies, makes up less than 5% of the universe. The rest is something else. Dark matter, dark energy. We cannot see dark matter. We cannot touch it. But without it, galaxies would fly apart. It shapes the universe while remaining hidden, and that alone should disturb us, because it means most of reality is already beyond our perception. What if intelligence exists in forms that do not emit light? What if it does not communicate with radio waves? What if it exists within structures we interpret only as gravity, mass, or motion? To such entities, we might not even qualify as intelligent life, just noise. Sometimes, when astronomers map the universe, they notice something unsettling. Entire clusters of galaxies are moving, not randomly, not away from each other, but toward a single region of space, a place we cannot see, a gravitational anomaly known as the Great Attractor. Something massive enough to pull galaxies across hundreds of millions of light years. We do not know what it is. We only know it is there. And then there are the wanderers, black holes that drift alone through space, invisible, undetectable, until they pass through a star system and tear it apart without warning. They don't announce themselves. They don't glow. They simply erase. Quasars, on the other hand, burn brighter than entire galaxies. They are powered by supermassive black holes consuming matter at impossible rates. They are visible across the universe. If any object were easy to detect, it would be them. And yet, they don't move. They don't approach. They simply exist, watching. So where does that leave us? A young civilization, less than a century into radio communication, barely able to leave its own planet, shouting into a universe that may reward silence. Maybe we are alone. That is the comforting answer. But there is another possibility, a far more unsettling one, that the universe is not empty, not hostile, not welcoming, just indifferent, and that the silence we hear is not absence, it is restraint. Because the most dangerous civilizations would not advertise themselves. They would not build glowing megastructures. They would not send messages. They would wait. And in a universe measured in billions of years, waiting is easy. The silence of the universe is not proof of safety. It may be evidence of intelligence far older than ours, intelligence that learned a lesson we have not yet learned, that sometimes the smartest move is to say nothing at all. Silence is not emptiness, it's a decision.